Hi, I want to talk about in this part of the lecture about a case study on recommendation, that is the YouTube recommendation system. So I'm mostly going to talk about the content of this paper, which is a really interesting paper that came out in 2016 about the YouTube recommendation system. The paper has a lot of details and a lot of ideas, and I think you should consider reading it. So the recommendation system at YouTube has different stages. The first stage is you take all of the videos on YouTube pretty much for a particular user, and you generate hundreds of videos that are candidates for this particular user. Then this basically first model is kind of a broad model. So it's just gonna try to go from all the possible videos to a subset of the videos. Then you have a scoring and re-ranking. And what those two parts do is a more fine-grained modeling of the user basically preferences. Okay, so the first is kind of a more of a general model, and then the other models are more detailed. Okay, so let's try to look into that. So first you have this is kind of a picture on how this works. So you have the video corpus, which has all the videos on YouTube. And then you have, these are millions of videos, and then you have, that goes into the candidate generation model. In that model also you can put like a user history and context. Context is everything around what is going on with the user right now. And that candidate generation model is going to generate hundreds of videos for each user. And then you have this ranking and re-ranking that takes into account other candidate sources, other video features, and that's gonna give like dozens of videos, which is gonna be the recommendation you're gonna get on YouTube. So what is this candidate generation model? So this is a model that is a bit more complicated than a matrix factorization model. So you're gonna see that it has some things that are similar, but it's a little bit more complicated than a matrix factorization. It's a neural network model. And basically what it does is it takes X is the user and other features, and the target is the video ID. So you're gonna be thinking video ID. So video ID. So how many videos are on YouTube, right? So this, they call it an extreme multi-class classification problem because the number of classes is huge. So the number of classes in here is the size of the corpus of that YouTube is considering training. They are using implicit feedback because there is a lot of more implicit feedback on YouTube than explicit feedback. So they are just gonna be using the videos you watch on YouTube as implicit feedback. And they're also using negative sampling here. And note how we talk about negative sampling back in the previous video. So let me show you a picture they have in here. So the main let's actually kind of call it a main idea. So this whole thing here is a neural network, okay? And the neural network is going to take a lot of features that I'm going to talk about, and it's going to produce a vector U. That vector U is going to be a vector that represents the user and the context. Okay, so for each user, you're gonna get this vector U that represents the user at a particular context. Okay, this is a vector, a k-dimensional vector. Okay, and then you're gonna have this vector is gonna be learned by the model. Okay, and then you're gonna have a bunch of vectors Vj. These vectors Vj are you're gonna have a vector per video. Okay, also learned by the model. Okay, and then at the end you're gonna be ranking each video by the dot product of U times Vj. This sounds kind of very similar to the way matrix factorization work, right? The only difference is that the vector U is gonna be learned in a more complicated way using a neural network. I know that we haven't talked about neural networks yet, so I understand that this is gonna be a little bit of more abstract for you guys. I just wanted to give you an idea of how this works, and then we're gonna talk again about this after we talk about neural networks, okay? So what goes into learning you? Let me tell you what goes into learning you. So first here we have all of the video watches. So every video watch gets embed. So we learn an embedding for every video watch that the user have had. And an average of those embeddings is gonna be passed to the model. We also take all the search tokens that the user have used, and we also embed them. And I'm gonna talk about embedding at some point very soon. So basically you learn some representations for every token the user have used. Okay, and this is another part of what goes into the input. Then it goes geographic information about the user, the age of the user, the gender of the user, and most likely any other demographic information that you may have. So all of this gets together and gets trained to form that vector U that gets to be a representation for the user. We also train vectors VJ for every video. And as I told you before, the dot product between U and VJ is the ranking of a video for a particular user. And all of this gets trained on a lot of users. Of course, we're training this on a lot of users and a lot of videos, okay? So how does it work exactly? So what we have, an observation is basically a particular watch. So I just go to YouTube right now and I watch something. So there is some context. For example, the context could be that, basically what are my watch history so far? What are my recent search history on YouTube? The context could be, my age, whether I'm logged in or not logged in, whatever, geographical embedding, the fact that I am in Berkeley, California right now. So all of that goes in and it's trying to predict what video I am gonna watch. So that's how this gets trained, okay? So this is the candidate generation model. So it is a neural network. And as I told you before, these are some of the features that gets added to this model, okay? At the end of the day, what we're gonna get out of this model is the top ranked videos for a particular user. That means the top videos J such that U times VJ has the maximal value, okay? And this is done via approximate nearest neighbors algorithm. So there are some algorithms that will rank based on dot products. Okay, so that's basically what we get out of this model here. So we get out of the model, we get all of these, say, hundreds of videos that are gonna be the top dot products VJ times U for a particular user U. Okay, so and that's the outcome of this candidate generation model. Next, there is a ranking model. And the ranking model is basically more fine-grained. So a lot of the features are more fine-grained. So they still have to do hundreds of engineering feature, okay? So for example, they use features like what's the number of videos that these particular users have watched on this channel? What was the last time the user watched a video on this topic? And then what we're trying to do is a binary classification. So either the person kind of click or didn't click on that video. Okay, so the main thing here, the model is kind of very similar. We're going to talk about neural networks very soon. We're going to talk about embeddings very soon. And I just wanted to give you this idea that this model is actually a generalization of matrix factorization. The good thing about this generalization is that you can use a lot of more features than just the user ID and the video ID, and this will give a lot of more robust models like the one that YouTube is using right now. We will go back to this model soon, and I'll show you more details on how to do this with neural networks.